Hi and welcome back to MDriven. Today I'm going to talk about OCL and some important operators in OCL. Operators working on collections. So how do I find these operators? Well, one good way is to just start a debugger and make this fit on screen, OCL operators, and list all the operators in the runtime. So these are the operators that are available, and some of them are on collections. One way to see if they are on collections would be to check what type they start in. So this is collection of any as set, returns any. There are also some operators that are only available in action language, but I want the ones that are in OCL. Those are the ones that we're going to discuss today. So if I were to sort on this and find all the ones that I want, maybe these ones. So these are only in action, so I don't want those, but we got some other ones. Let's see. Yeah, so these are the ones that we might want to discuss today. I'm gonna copy those and let's head out to Notepad. Yeah, so we can remove the ones that are not in OCL. They will have false in this second column. So not that one and not these. So what's the difference between action language and OCL? Action language is something which actually is able to change data, and that's not standard OCL. It's something that is specific to MDriven that we introduced in order to actually do operational work on information. OCL is transformative. It's a functional language that only takes inputs and delivers something else, something new as output. It never actually changes anything, and that's an important aspect of the functional nature of the OCL language. So there are quite a few, but we're going to focus on some of them. Going to highlight and lift someone because they are more interesting than others. I guess so these are the ones that we're going to talk about today. In order to do that, it's good to have sample data. So I'm going to take some time to set up an environment where it's easy to see what happens with the when I apply the different operators to some data. In order to do this, I have this plan that I'm gonna have a class. It could be named anything, so why not name it anything? And since I will do it a singleton, it's good style, at least I think so, to name it singleton as well. And it's not enough to just name it. That's just good convention. I also need to mark it as being a singleton with setting a singleton true. So that means that there will be one instance of an object of this class. And why I want to have this is because I want to have two collections of things to work with. So that's the first collection, and I'm gonna call that thing collection 1. And then I also want a second collection of things. I can remove this from view. Just press delete, and that means that when I remove it from the diagram, not really from the model. And this other collection I'm gonna call thing collection 2. So that means that I would have the ability to make a view that shows 2 collections in one. So let's go ahead and do that. And I'm gonna do a new view that is gonna be rooted in this anything singleton. And basically that doesn't need to be rooted as such, as I can find the singleton instance by other means. I'm going to add a generic column and write an expression to get hold of my singleton object. So anything singleton, that's just the class name, and then there's an operator, and then there's an operator. Oops. Called OCL singleton, which is the one that actually gets me the one and only instance of this class. If there wasn't any created as of the time me running OCL singleton, one will be created. Good. So what does that mean? It means that I have the singleton object, but that doesn't really help me. I want to show some stuff from it. I'm going to do a nested view model. I'm going to do a single link here, and just add another nested view model class. Gonna have this associate to that view model class. So let's call this view model anything, and do a global action so that I can bring this view up, and that will show anything. Well, it's a name as good as any. So this nested will of course be typed of anything singleton, and I can call that my instance. From here I can add a nesting to create and delete stuff in thing collection 1 and thing collection 2. And now it dawns on me as I say this, that what I really want is to be able to have the same thing in both collections in order to test some of the operators that we're gonna see, like difference. And that means that if one of my things is that's possible because I have 2 collections. So I was this will work nicely. So I can put the same thing in both thing collection and thing collection 2. So having said that, we might want to show all things. We're gonna do a so I'm going to do a list to show all things initially. And how would I do that? Well, thing all instances. And that will be a collection of thing. Okay. So I'm going to call that column all things. And then I want yet another nesting to actually show that. So I'm going to add another nested view model class, and that's going to be typed to thing. And this one going to be associated to this new one. I'm going to call this new one for things. And the columns to show in that one is going to be pretty much the sum string. That's enough for me. So I will have one grid over here showing me, misspelled something here. Showing all things. And I also want to, now I can use this all menu option. So the multi-link to show the thing collection 1. And I'm going to put that over here. And also the thing collection 2 then. And put that over here. And what I want to show in the second grid is actually the sum string as well. I'm going to remove the as string, and also the sum string, removing the as string. All right. Not really interested in adding details here, so I'm going to opt out these actions. They are still there, but I just don't want to see them. What I do, however, want to see is a way to create new things. So I'm going to add an action, a view model action on this one, and I'm going to call that. That Windows was way too big. I'm going to resize it. I want to call that action for add new thing. And what that actually is going to do is just thing create. Yeah, so that will be a thing, and possibly I want to set the sum string, assign it to a value called, let's say, new thing. Good. Let's not do too much before we try things out. So we're going to start this, and one perfect way to test things and start things out is to run the live edit, because that's a mix of actually doing things and designing things, or rather designing things and running things. So I'm going to restart the turnkey server in order to run towards this model that we have open here. And then in my live edit I should be able to see my application, which has the action show anything, and the show anything will have these 3 grids on it, and there's a add new thing action available in it as well. So that's good. I'm gonna push this one a couple of times and hit save. So I have a couple of new things. Immediately it dawns on me that I have no way to actually edit the name here. So that would be good if I could. And I can turn on advanced edit here and say that it would be good if this grid over this one here actually could edit the value of some string. So to start that off, first of all, the read-only expression of to control this shouldn't be true, meaning read-only yes. It should be left blank probably. That would allow me to at least by expression edit. But then again, this is a web UI control and that doesn't natively offer any edit. We need to instruct it that that's what we want to do. And we do that by assigning a tag value on the nesting, and the tag value is called editable. I'm going to add that tag value and say that the value should be true, meaning that I really want this one to be editable. Now this is editable. That's good. So cool. Now I have all the things, but I don't have any way to get things into collection 1 or collection 2. So maybe I need a couple of buttons to actually have values show up here as well. So where are the buttons going, I wonder? Well, I guess we can make some room by just moving this 2 steps to the side and this 1 step to the side. And now I want to add a button here, and I can actually just go here and add a column and add 1 button. Let's add another button while we're at it. So now we have 2 buttons and it's over here. Button 2 should go somewhere here maybe. And that didn't turn out very nice. I'm going to move this one to the side. Button 1 can go over here. And that didn't turn out very nice, so I'm gonna need to move all the things to the side. When so currently I'm in the design mode of grid layout, and then that's good for some things, but it's not super perfect. It means that there are a lot of things to move. Once you want things to move, let's see if I can move this one. Yeah, and then I need to move that one over here then. So another approach would be to use CSS grid. So CSS grid is a totally different way to handle layout, and that's the preferred way to handle layout on the web. It's basically what we call in HTML language we would call flexbox. So I'm gonna do that. I'm gonna turn this whole UI to a flexbox UI by adding a placing container that controls the layout rather than the CSS grid. And there are 2 settings here. So this turned out to be a column. I'm gonna hide this to see how it looks. So I have a column here, and then everything follows like this. That might be good, but we might just as well think of this as being not a column as much as a row. And if this is a row, we first get the buttons, and from there we will want to have so in order to get these tables here up in this red placing container. I'm going to need to add a placing container to this singleton here. So this goes here and we get all the grids in a column. That might be good. That might be okay. This one, we could make that a column now that they are on the side. We might want this column to consume more space than this one. So in order to do that, we're going to tell it to grow and advanced edit. And we want this column to be able to grow. And that is denoted by a value bigger than 1. So now it grows, but it still doesn't actually show, probably because it's stuck in something that limits it. So this one, yeah, okay. So if we were to turn off edit here and just watch what we have something where we can do add new things, and we can edit them, but we need to be able to move them into the collection that we want. And how would we do that? Well, basically we can call this button here for move to 1, and this other button move to 2. So what's the logic for move to 1? What is it that we want to move? Well, it's the things in thing. So probably the selected things. And then we go vSelected, which is a variable managed by the runtime, the MDriven runtime. And this one is called things, so this is the one that we want. And we want to, for each of those, let's call a loop variable t. What do we want to do with that? So this action we are editing now is the one called move to 1. So probably for each thing that was selected in this grid when we push the button, we want to add it to the anything singleton thing collection 1. But anything singleton in this context is, we need to look that up, OCL singleton. So the first one is just for mentioning the class, the second one is to actually find the instance, and then we have access to things collection 1, and we can do add to that collection T. I'm going to copy this expression because the one we're going to do for button 2 is frightfully similar. Just going to add to thing collection 2 and turning off live edit to test things out. If I select this one and say move to 1, it pops up here, and also I can remain on this one and say move to 2, and it pops up here. So that's good. Good. Yeah, and this is a warning that I get that I've accessed the variable called v-selected, but I haven't told the UI to render this table as multi-select. So that would probably be a thing that I want in order to be able to select many rows and say move to one. So let's do that. That's also a tag value on the nesting, denoting the table as such. So selecting this one and advanced edit and tag values and choosing multi-select, adding that and saying that that would be true. And that makes it possible to select multiple things like that one and move to one. And then there are two that's moved here. So that's good. This is all and well, but I would actually like, before we start to actually check out the operators, to visualize them a bit better, not just calling everything new thing. One way to visualize is to use styles. But we're going to make these tables here a little bit different. We will make them as placing containers, list views. So pretty much what we do is add placing containers on them, on both of these. And what that enables us to do is that they are rendered differently. Okay, now it's really hard to see which one is which. So we need to sort that out. Which one is which? So now they are both in the same thing, but what we can do is to put a style on the outer placing containers for both of these. So the style expression could be basically just a constant. Let's see if how we will go about doing that. On this, I want a style expression, and to find styles, one can go self VM, which is the self for the whole view, and find the collection of styles and discover that that is pretty much empty, but we're going to call this section 1. So that will give us an error because we don't have section 1 at this point. How do we define styles? Well, of course you can do your own CSS, but that's not what we're going to do today. It's a faster way to keep it within the model, to create a style and call that section 1 and say that the target for this style is a placing container. And saying that we want a border on that one. And that border should have a fill color. We don't have any color, so we're going to add a color. And going to make the first border green, that kind of green. Call this green to make things clearer, and another color. I'm gonna make this second one red and call that for red. So now the section 1's placing containers should fill with green. Or rather, this is a border, so that's actually a stroke color. So it should be stroked by green. And gonna do, can copy this and paste it. At least I thought I could. Section 2. So the section 2 has a copy. Oh, too bad. I'm gonna fix that later. And the stroke color on this one can be red then. Let's just set the fill color. So the border, let's make that 2. Having said that, we head back to this. We already did this one, style expression section 1. And then we can do this one, style expression section 2. And what we want to see would be some kind of indication that these see, why aren't we getting any styles? So we are on the placing containers, red and green, section 1, section 2. We have fill colors. We have the border. Okay, I went off camera a bit because I was stumped by not getting these styles to work, but it turns out that I was wrong. According to the definition, when we style list views like this, the style should actually be on the outer control, defining the whole thing. So instead of setting the style on this placing container, which I did, I should have set it on the outer control, defining the whole thing. So I'm going to change that now. In my desperation, I put the style also on the row, and that explains why it actually worked, because each row was colored, making the appearance of the whole being colored. What I should have done was to put the style in the style reference. You can say that it's an expression, and the section 1 there. And the same for this one. I should have removed here, also removed here, and put that style up here instead as an expression. Having done that, it's still not showing anything, but that's because I targeted a placing container when I in fact probably should have targeted a component. So I'm going to do that and say that the fill color should, I'm going to go with stroke color, should be red, and the border should be 2. And for the section 1, also component, add a stroke color green, border size 2. And now I get a green border around one of them and a red border around the other one. So that's what was the effect that I was going for. Good. Yes, back on track. I also want to make each thing in collection 1 or collection 2 a bit more interesting to visually interesting. So what if we can go back to styling? Let's do a couple of styles that we're gonna call their color name. So we're gonna call one red, and I'm gonna call one green, yellow, purple. And for each of these, again, I'm gonna go with the this time I'm gonna do placing container and say that the fill color should, I'm gonna do these colors as well. So green and red we have, but I need a purple one. And purple is more like this. I'm gonna call that purple. And I need a yellow one. Like that. So for the green, placing container, fill color green, and I'm gonna try to make these look like little round circles. So I'm gonna have a border in order to make it possible to set the radius on the border to let's make that 15, and we're gonna do the same for the purple one. And the fill is gonna be purple. I'm gonna have a border and put the border to 15. And for the red one, and for the yellow one, and then I actually gonna for these the display inside here, I want to make them maybe static, and what that means that that doesn't really it's rendered like that instead of a frame around it. That's good for my purposes. So I'm gonna do the same for this static, and then I don't really want the header to be repeated all the time, so I'm gonna remove the presentation. And also for this. And on the style for each row, I'm gonna do a style expression, which basically is self dot some string. And what do I do there? Well, I take the data from the object in the row and say that that is a style. I'm going to do the same thing for this one. So let's see how that behaves. So there is no style called new thing, but there is a style called red. And there is a style called green. Good. So this way I can make things stand out a bit more. Yellow. Have to spell it right. And purple. But that wasn't, I'm gonna add that one to 2. All right, but I said that I wanted more like these are very elongated, so can we do something about that? Let's save this. So on this placing container, we could say that there's a primary in X direction and the max display, maybe make that 30, and do the same for the lower one, since I had the radius on the style to 15, double that, will make it 30 and make these look like little circles. So that was the effect I was going for. Maybe we should do yeah, now the value and the text on these, even if we have multiple reds, they will all be called red. What I mean is we're gonna add a few more things and call them all red. And select them all and add them to 2. So this might be confusing because they all look the same, but they are different objects. So can we fix that somehow to make it clearer that they are different objects? Well, instead of just displaying the value here, we could display something else. For example, we could give them an index depending on where they are in the collection of all things. So that would mean that we would give it an expression in the style of like thing all instance says index of self. So that would be one way of doing it, but it might become inefficient to ask index of all the time. A much better way would be to make this a derived attribute on the thing itself, because then it's just evaluated anytime it's needed. So I'm going to do that. I'm going to say self.identity. But there is nothing called identity, so I'm going to add a new attribute to the type thing, the class thing, and it's a string, and it should not be persistent, it should be derived. So now it's derived, okay. But I still need to explain how that should be derived. I've just said that it's supposed to be derived. And the thing all instances index of self would be fine, but that's an integer, and we said that it should be rendered as a string. So but then I can go like as string on the integer. There's two s's in as a string, and that way I would have I can call the label on this to reduce confusion for myself, and identity, and this way we would have unique numbers and all. So that's good. Now we can actually start to do some we started out saying that we should try out the different operators. So that's something we should then try. Good. Making progress. So here we have the two collections. What if we add a third collection? So pretty much I'm gonna copy this and paste it. So this is we're gonna call this result collection, and the result collection I'm gonna call this results. But this is actually the good place where we're gonna be able to show what happens with the different operators. What do I mean? Well, we have the thing collection 2 and 1. So what would happen if we were to take 1 and apply difference with collection 2? So that's one way of applying this operator. I can, let's just bring up a web browser to, if I have one already. So the difference between this collection and that collection is 1 and 3. Having this and removing all of these leaves 1 and 3, because the only one that was in both was this 0. So that seems fine. What if the 5 also had been in this one? Okay, now I see that I don't have the identity here, so it's hard for me to know which one is which. Let's fix that. So in this grid we can also add a column for identity, and we can make that static because it's derived, so we're not able to change it anyway. Having done that, I can see which one is which is good. So what did I say? If also the 5 were in this original one, then we would suspect that that would yeah, that wouldn't make any difference. Let's try that. We're gonna add the 5 to this collection, move to 1, and that's really no difference because it will be subtracted from here. But if we were to remove 5 from this, okay, I don't have any way to remove a thing from these, so let's fix that. I'm gonna add a button up here. This is actually a very good example of discovering that even if you think that you are done, as soon as you start and run your thing, you will discover that there are more things to do. So I'm gonna call this remove from 1. And how would I go about removing from 1? Well, I need to find which one is the selected one. So let's see what the nesting is called. The 1. So I'm gonna change name to make this clearer. Thing 1s, and then consequently thing 2s, because there are many. So for the first button, which I called remove from 1, I want to take the current one, the selected one, of thing 1s, and actually remove that from my thing 1 collection. So again, anything singleton to get to the class, OCL singleton to get to the 1 instance, and in the collection 1 I want to remove the currently selected one. I'm going to copy this because what I want to do for the collection 2 is very similar. Remove from 2. But then I want to think collection 2 and remove the one that is currently selected in 2s. So I was saying that what will happen if this one okay, cancel. I was looking at the wrong one. So this is the one that I'm gonna, if I select number 5 here, I'm unsure if it's selected. Remove from 2. Yeah, then the 5 disappeared from there, and consequently it showed up here. Gonna do cancel. So the 5 is not in the difference because 5 subtracted with 5 leaves nothing. 1 subtracted from not having 1 leaves 1. So this is how difference work. But if this 5 were removed from this this collection, like it was now, then 5 remove non-existent 5 will make 5 survive in the result. So that's difference. Good example. Yeah, luckily that was on screen. So that was that one. Reject. What does that mean? Yeah, let's defer these because these work on a single collection. Symmetric difference. What's the difference between difference and symmetric difference? So the text for this is collection 1 minus collection 2, the rest is returned. Symmetric difference. The sets containing all the elements that are in set 2 but not in both. Okay, let's see if we will get any change. This is one of many things that is easier to actually execute than to think. The symmetric difference, it sort of checks it's a collection of all the things that are unique in the 2, so to speak. So since 6 is only in one of them, it survives. 7 is only in one of them, it survives. And so that's a difference. That's different than what difference did. So symmetric difference is not the same as difference. So difference is you have this and you remove everything that is mentioned here from there. What is left? Symmetric difference is you sort of remove everything that is equal. So 0 is in both, so it's not going to survive. What if I remove 0 from this one? Remove from 2. Then it survives. So if they were completely equal, 0, 1, 3, 5, I'm going to remove number 4 from here. And number 6. And number 7. So symmetric difference of all of these and none is the same as the input. But that would mean if I were to add 0, 1, 3 and 5 to this one, I would end up with nothing here. So let's try this. I'm going to add 0 and 1 and 3 and 5. 2, 2. And all of a sudden we're left with nothing. Cool, good example. So we talked about these two. So we're gonna excluding. So let's try that one. Yeah, so this actually doesn't want a collection as argument. It points out one specific object. So in order to test this, I can have the collection 1 and excluding, but I can't use the collection 2. But I just need one object. So I'm going to take the first object from collection 2 to show this. And that's another operator called first. So then it's okay. And that means that if I have this and excluding the first one from here, from this one, I get 1, 3, 5. So this result minus the first one from here. So if this were to change that let's see, remove from 2. Now number 4 is the first one, but that wasn't even in here. So it's nothing is really excluded. But if I were to add number 4 to here, so that number 4 was part of this, it still wouldn't survive here because it's first here. So I'm going to add, move to 1. So it didn't make it here to the result. But again, if it was removed from here, it would make it to the result. Let's add number 5 to, yeah, let's do it like this. Remove that and add number 5 to the 2. Oh, sorry. Move to 2. So now number 5 is here. Everything survives because 6 is not in the list, so everything survives. But if I remove 6, no change really. But if I remove this 7, number 5 will be the first one, and then number 5 will be removed from, will hit this one, and this will be reduced. Like that. Good. So I'm skipping some of these because they return Boolean values, and I'm more interested in showing the ones that work with the display that I have now. Yeah, the one obvious one would be these order by. They all pretty much work the same. So now I have 0, 1, 3, 5. Yeah, they are already in order, but let's say that I want to display them in reverse order. Then I can go like thing collection 1 order by, or rather order descending then, in the reverse order. And the loop variable could be anything. I will call it t, and I can have any arguments here. I will call it t, and I will take the identity or the derived attribute that we used to denote the numbers. So then this one will be in reverse order, 5, 3, 1, 0. So all of these work pretty much the same. Let's do this one, union. Returns the union of the list and the list in the parameter. So that's straightforward. It actually is a plus, an addition of things. So union of self collection 2. So if I have 1, 3, 5, and now it's interesting to what happens if 0 are both in 1 and 2. It's still only one time in the result. And this is an important aspect of OCL as such and UML as such, that all results are basically most of the time sets, not bags. Sets means that identity is important. You can only think of it as objects. If you have one specific orange, it can only be one time at any one place. So it would not make sense to put the orange in the bag twice. It still would be there as a single instance, right? So it's not strange really, it's just sanity. But it's an important principle that doesn't come natural to programming development, but it will reduce the number of errors that you accidentally do, because this works as you think and as the world behaves, and that's good. So union, if I were to remove 0 from number 2 here, it's still in the bag, in the resulting set, unless it's also removed from number 1. Well, then it's not in the union of these two. Good, that's union, good example. intersection. This is a good one of my favorites, if one is allowed to have favoritism in OCL operators. So intersection, let's see what it says. Returns the list, yeah, maybe it's not even on screen. Returns the list of all elements in the list and the parameter list. Yeah, that might not be the perfect wording, but intersection, as the word alludes to, it's the cross between what we have here and here. So what's the same? So the difference was what's not the same. Intersection is sort of the opposite. What's the same? So 0 seem to be available in both places. So that survives. If we were to add like 7 here, oh my god. 7, I'm gonna add that to number 1, and we would expect it to pop up from here, because now they are in both. And if I were to add number 3 to number 2 here, I would expect it to show up here. Yes. And to allude to the same thing I said before, that things are only put in the bag once. You can't stand in queue in multiple places, of course. You're only one person. And if you're only one object, you can only be in one place at a time. So this number 3 yellow, it's already in number 1 and number 2. If I move it to 2 multiple times, nothing really happens. If I remove it from 2, I didn't remove number 3, I removed the one that was selected. I'm not going to select number 3, remove it from 2, and then I can move it to 2 again. So to summarize, maybe we should call it a day there and leave these operators to another video. To summarize, the operators are mathematical constructs that are logical and that will always do the exact thing that they were designed for. And they can, when you start to think in sets and in objects like this, it will greatly reduce the amount of imperative things you need to think about. I need to add it here, I need to remove it from here, I need to make sure that they are not the same. You can use these operators to cut through and get to what you're trying to convey. And they are really important strategies on how to manage information. So that's it for now, and thanks for listening and watching. Thank you.